So our next speaker is one of our gold returnees. She's Tanya Jones, and she was in a previous life in the preservation business. Her company, which was called Alcor at the time, dealt in bodies or heads or both, cryonically frozen in the hope that sometime in the future science, medicine would develop so as to be able to cure the thing that damaged the person being cryonically frozen, in the hope that there would be a better day. At the time, I think she was also looking ahead to possibly reanimating those body parts with a view to somehow joining cloning, de-extinction, resurrection, reversing as techniques available to all of us to possibly extend life. So I hope I've got all that straight, Tanya, and I haven't stolen your thunder. Thanks so much.
All right. Thanks, Moses. At Arigos, my new startup, we are based in Silicon Valley, Mountain View, California, and we believe that we're developing a method that will actually give the world organ banking for the first time. The need for organs is pretty dire. In the United States, 120,000, almost 121,000 people are on the transplant waiting list, and more are being added every year, despite transplants being occurring on a regular basis. That number is just going to continue to grow because we've got an aging population. Transplants are the treatment of last resort. Those numbers, that 121,000 number, does not actually reflect the entire need. Cystic fibrosis patients, transplants, last resort. End-stage renal disease, last resort. These are the real need that organ banking can cure. So instead of just 100,000 people needing kidneys, when you get on the transplant waiting list, you're already very, very sick. A lot of people die while they're waiting for an organ, and many people are too sick to even be added to the list. So 100,000 compared to the 930,000 people who are suffering from dialysis, they deal with dialysis, they wait on the waiting list for 5 years. The quality of life is extremely poor. You go into the hospital a few times a week, they filter out your blood, and you just wait. So the cost in the US for these nearly 1 million people is about $42 billion a year. If we had organs to give to these people, the cost of the transplant operations can be recouped within 1 to 3 years, and then they're eliminated. Not only is the quality of life improved, but the life expectancy after transplant increases significantly. Now, in Canada, you've got an interesting situation. Your costs will be recouped in less than a year because it actually costs more to maintain a patient on dialysis than it does to provide them with a transplant. Now, you may be wondering, don't we have banking today? And the answer is no, we do not. Organs are fleshed out when they're harvested and put on ice and rushed from the donor to the recipient. In many circumstances, patients, people who are on the waiting list, will relocate to be near the transplant center so that as soon as an organ becomes available, the operation can proceed. In the case of hearts, 4 hours is about the time frame, so you really have to be on site. Other organs will last a little bit longer, but nevertheless, you have to be very, very close. So if we could bank these organs, if we could put them in storage for a little while, this would alleviate many of the problems that we face. Now, why don't we have banking? Well, these are the 3 reasons why. Ice formation. Everybody knows 80% of your body is water. You cool water down below 0, ice forms. Ice will crush the cell membranes, which prevent the organs from being revived. Now, that's actually a solved problem. This is solved by a process called vitrification, where the water in the body isn't actually forming ice crystals, it forms kind of a glassy solution. The process is called vitrification. But the solutions that are used to eliminate the formation of ice are actually in themselves quite toxic. Furthermore, the way science sometimes goes, when ice formation was solved, it uncovered a new kind of damage that we didn't know existed because it was obscured by the previous problems. And that is stress fractures. These are, because organs are cooled from the outside in, there are thermal gradients that cause fractures to form in the tissue when you take it to low temperatures. It's kind of like taking an ice cube and putting it into a glass of warm Coke. You hear that pop. That's what happens to tissue. Our technology is really very exciting. This meeting is entirely about combining new ideas, being exposed to new ideas. What we're doing is combining 3 different technologies to solve all of these problems in one fell swoop. Vitrification, that's the part that prevents the ice formation. Persufflation, don't be surprised. I wouldn't be surprised if you haven't heard this word before. It was new to us as well. This is research that was done in the 60s and the 70s using oxygen to wash out the blood and see if you could maintain metabolism and hopefully transport an organ a farther distance. It didn't work as well as some of the solutions that were being used at the time, so that line of work was largely abandoned. Well, it turns out if you combine those 2 methods, and rather than using oxygen, if you can use helium, which is still a gas at very, very low temperatures. We're talking liquid nitrogen temperatures, which is the same blood cells, embryos, things are commonly stored in liquid nitrogen. You can maintain systems in liquid nitrogen if you can get them there safely and warm them back up for indefinite periods of time. In fact, recently, in the past couple of years, an embryo was transplanted after 27 years and a viable, healthy baby was born. So we know it will work for the long term. But it only works for very small samples, things that are 3 cubic centimeters or smaller. But if you add persufflation and vitrification, you've got a circulatory system. You wash out the blood, you put in the solution, you prevent the ice formation, and then you flush that out with the helium. And so when you cool the organ, which you can do very, very fast using this method, it's not like ice, where it cools from the outside in. It cools from the inside out, so it's very, very quick. But helium is still a gas at those very low temperatures, which means as you cool the organ, you've got a bit of a crumple zone, a crush space, where if there's any stress coming from the changes in temperature, it's immediately relieved by just a little bit of deformation of the circulatory system. So the photos you see up there are CT scans of some of our organs. One of the interesting benefits of applying this method, it turned out to be that you can actually see some of the structure of a kidney, which previously you couldn't using just traditional imaging methods. So the toxicity, that was a real question for us. It is a serious problem. You don't eliminate toxic effects until you get tissue below about minus 123 degrees Celsius. And that's about the point where molecules stop interacting. They'll still sit there and they'll still wiggle a little bit, but no additional damage is being accrued. So you have to get below minus 123 as quickly as possible. Surface cooling, we use this in this is a mathematical formulation. It is not demonstrated yet on the rewarming side, but we have determined that we can cool sufficiently quickly using our method that over 99% of the toxic effects are eliminated. So combining that with the lack of ice formation and the lack of stress fractures and we think we've got something that will work. So we asked ourselves, how realistic is it to think that we could build a bank? How long would it take? And the answer honestly surprised us. The numbers you see behind me in this table are absolutely the most conservative numbers that we could come up with to figure out how quickly a bank will be established. In 2012 in the US, there were about 25,000 transplant operations, and many of those came from deceased donors, people who donate their organs upon death. There were 8,000 donors in that year, 25,000 transplants. What happened to the rest of the organs? Well, they were discarded. They were thrown away, they were unused for many reasons, but to a large degree, there were no recipients available immediately close enough to get the organ between the two. So what if we could bank all of those organs? What if we made it standard practice to just harvest everything and throw it in a bank? What would the impact be? Well, it turns out, using this very conservative estimate, we could eliminate, assuming matches, 5 of the transplant waiting lists within a single year. We kind of find that exciting. Doesn't address the greater need, things like end-stage renal disease or cystic fibrosis, but it's a start. Now, what would be the benefits? Can we be more concrete here? 24 hours. If we could only just have them hold on for 24 hours, we could deliver the organs anywhere in the world. If we do it for a week, then all of a sudden it's not an emergency procedure done at 3 a.m. just because that's when the organs tend to become available. You can schedule it. You can have your fresh team. You could have a healthy-ish patient. They're not emergency procedures anymore, and that will contribute positively to long-term survival. If we could do it for 6 months, there are emerging stem cell therapies on the horizon, some of them in clinical trials right now, that should eliminate transplant rejection entirely. And the process involves taking some of the donor cells and performing kind of an immune adjustment on the recipient so that the body is given an opportunity to become used to the organ long before it's transplanted. So we've got high hopes for that technology as well. So if you want to help, think about becoming an organ donor. Inform your family, because sometimes transplants don't go through because the family doesn't know that you're informed. We're a small, scrappy startup. We always need money, so fund our work. Introduce us to cool people. We're sufficiently confident in the work we have ahead to develop this technology. We're halfway done. We're in the process, we know we can get them cold. We're in the process of designing the device to do the RF reheating, the radio frequency reheating, that will allow us to rewarm the organs and begin looking at recovery data and eventually full resuscitation of the organs. But it turns out there's a tiny little gap in the scientific literature that we need some data to correctly design that device. And that is the fact that nobody's really looked at the conductivity of temperature of tissue at these very low temperatures, obviously, because what was the point? It was unrecoverable. Well, not anymore. So once we fill that gap, we'll be able to develop the rewarming side of the equation and really establish whether or not this is going to work. So in an attempt to prepare for moving forward, we don't know very many people in the transplant industry or in patient advocacy groups. So if you know anybody who would be positively impacted by this technology and might be willing to give us a little advice, we'd love introductions. And then, just to show you it's not all smoke and mirrors, this is our first Persufflation chamber. This is the device that we built to establish that these cooling rates, very fast, will work. We're excited about the opportunity. We've got a confident team that's very passionate about what we do. And if you know anyone who's possibly suffering from one of the illnesses where transplant is the last possible effort to save their lives, let them know that help is on the way. It'll take us 5 to 7 years to develop the technology through the clinical approval process. This is device development. It's not small molecule drug development, so it takes less time given the way the FDA and other approval bodies work. So it's on its way. Hang tight, and we'll get it to you as fast as we can. Thank you.
Tanya, for the sake of the people who didn't hear your previous talk, you ran a company that seemed very oddball, right? It catered to people who hoped for a better day and were willing to pay money to have their remains preserved in the hope of that better day.
Yes. One of the main reasons I left that company is that there was no research and development. Organ banking is a step along the path to amazing vistas like interstellar travel. It needs to be a reversible procedure in order to save these lives. This is what I'm doing now.
Sure.
And it's
how many bodies did you actually hold in that previous company?
There were about 100 at the time.
So 100 people were persuaded that there was some hope of a kind of resurrection.
Well, they were hopeful about the potential to do things like develop medical nanotechnology, tools. I mean, human beings are amazingly innovative. So we can imagine a future where there are little devices that can go into a cell and repair it. The hope is there. Whether or not any one of those people will be recoverable in the long term is an unknown. I want a process that is reversible today.
Right. So you're trying to make that transition from a kind of technological and social fringe into a credible and legitimate industry.
Yes.
I have one last question for you. Why don't people donate organs?
I don't have a good answer for that, but I think part of it may be because of that fact that a lot of them go to waste. If you knew that if you donated your organs, you would, with greater certainty, save 8 lives, isn't that gift worth giving?
Yeah. It's interesting, though, that only a small percentage of people actually sign that little card that we all get. And the reasons why people hesitate and why people don't quite take that last step are very intriguing. One province in Canada is actually thinking seriously about making it a fail-safe process. Rather than depending on altruism, it would be an automatic thing unless you took the trouble to opt out.
Actually, Moses, in Europe, that is, in some jurisdictions, that is their law. It's an opt-out instead of an opt-in. And yet you still don't see the supply available to meet the demand. But perhaps with this technology, Europe can become a net exporter until the rest of us catch up to that sort of system.
Who's your client?
Pardon?
Who would be your client here? Who's going to pay for your research and your storage?
Well, who's going to pay for the research? We're working on that.
Right.
Peter Thiel contributed some funding, as did some...
You see yourself as a charity or as a corporation?
Oh, no. We are a for-profit corporation. We're protecting our IP. We intend to develop it. Who might work with us? We've had some conversations with General Electric. We're a little too early stage for them, but they've got, when it comes time to do worldwide distribution of our technology, they might be some of the one of the companies that we work with. But every transplant center, what we see is every transplant center in the world should have both sides of the equation, the ability to cool organs and bank them, and the ability to rewarm them so that they can be transplanted. It's possible that every hospital in the world should have the cooling side, just so you can take the organs when they become available, put them into the transplant system, and send them to a facility where they can be best utilized.
If your dream comes true, we'll have a mountain of organs instead of a rare organ. And instead of it being deployed strictly in extreme cases, I might just be able to call you up and say, I need a new something or other. I'm not
It's even
on
more
the brink of
exciting
death,
than that.
but I'd like to refresh.
That's true. That possibility exists, but I neglected to mention that organ donation, in the way it's performed today, is likely a doomed industry. Because what you're going to want when it's time for the new kidney or the new liver, whichever, you know the day is coming where you need that. And so you have one created from your own cells and banked. Tissue engineering is on the verge of some amazing things. Bladders are grown in the lab today and transplanted. People may have heard of the trachea that was transplanted a couple years back in Spain. The patient's own cells were used to create that trachea, and it saved her life. So you'll want one that's created just for you, not somebody else's.
So there's a business idea for you, an entire bank of preemptive organs made out of your own stem cells.
Absolutely.
I'm in.
Glad to hear it.
Thank you.
Thank you.
Hold on. Take that picture.
Good job.
Thank you.
Oh, this is great.